Thank you for joining us on YouTube. Today's study group session is going to be focusing primarily on getting started using Google Colab and similar cloud hosting services, as well as how do you set up Keras and TensorFlow on your own machine at home so that for following along for the class. The study group is specific to the postgraduate AIML certification course that me and my fellow study group are going through. There's also some deep learning stuff that we cover as well. Future study sessions will go more into deep learning. I'll include the GitHub page and some of the links as well in the YouTube comments. Anywho, thank you guys for joining on this. And the other thing I'll mention, it goes into how to install Keras and TensorFlow. The last time I did it, it was more complicated because I had to do a little bit more version control because there was and set up a specific environment specifically for TensorFlow and Keras because it didn't play well with a couple other packages. Currently, I didn't see any need for it during this install, so it wound up being a very simple and straightforward process. Hope you don't find that to be too much of a waste of your time. Anywho, without further ado, here's the study group. And because I've now just started recording and I'm going to probably upload this to YouTube and share, essentially I'm going through some basics of using Google Colab for deep learning projects and the differences between deep learning frameworks. The differences between Google Colab notebooks and some of their competitors, as well as hopefully also including how to get TensorFlow and its dependencies set up on your own machine. Okay, so everything before this was, if you want to get started with Google Colaboratory, you can easily just go into any search bar and put in Google Colab, and it's the first result that'll come up. The notebook that I'm using for demonstration purposes, if you go to the What is Colaboratory, which is the basic notebook that always starts up on when you begin, and scroll down, there is the First Steps with TensorFlow notebook right here. And for that, we're just going to take that notebook and run everything down to the last, just down to the second to last cell called Task 1, achieve root mean squared error of 180 or below. So let me check something real quick. If I run this again, no. Okay. So when I changed the runtime type, so I went from using nothing. So actually, just to explain what this is real quick, if you have the accelerator version here, if you have, or when you see notebook settings, you're going to see one of two windows here. If you have Google Colab standard, if you're using the free version, which is what I'm using right now, I have used premium in the past, but I only have that when I'm running competitions, and I'm not running competitions right now. If you have standard, all you're going to see is the hardware accelerator version here, and you can select between none, which means that you're going to have a CPU doing all your computations. You can have it'll show GPU, and then there's TPU. GPU stands for graphical processor unit, which is a video card essentially, and TPU stands for tensor processing unit, which is is like a video card, except the cores on it are optimized for computations, or for doing computations instead of image throughput. So I'm not going to use a TPU on this, but if I keep this as, if I change this to none, and notice the runtime changed, and I go, I'm going to select here, and then I'm going to go run before, and this is just going to run everything up to this point. So right now it's putting all the packages together so that it can run this here, which is training a model to run computations on a very simple tabular problems. So this neural network is trying to do, is working on a data set called the I want to say it's the California house price prediction data set. Let me see. Yes, California house price prediction. It's a very common one to be working with. You'll notice that takes about 10 seconds per iteration. And what you're seeing here is the actual epochs for each training step. Don't worry too much about the numbers you're seeing here. Just notice it's taking about 10 seconds per step, give or take. And this is running it on a CPU. If instead, I'm going to cancel this, and that was not the right one. I go to runtime and I change runtime type, and I'm going to go to GPU. I'm not going to mess with TPUs right now. The session will restart, so I'm actually going to have, you'll notice if I try and run this again, it'll say this is not defined. So I'll go back to runtime and I'm going to hit run before to get back to where we were. Are you guys actually able to follow along? I feel like I'm rushing through this just to catch back up with where I was before.
I'm right with you.
Okay.
Also, don't worry.
Okay.
I'm digging the pace too, because usually when I watch the videos from for the class, I usually play them at like time and a half, because there's way too much time. Like, it's like I don't have this much time to just sit here and watch videos. Like, let's get to it.
I will admit the rate at which some of the speakers speak kind of is a little bit grating to me. They take a bit too long.
Yeah.
They speak too slowly for me. So now I'm going to go to train model, and it should take less time per iteration. Let's see if it's up. Actually, I don't think there's anything here telling it to run the computation on a TPU or instead on the GPU instead. Let me give you a slightly different example with some better visuals. So this here is Colaboratory, and as you've noticed up to now, we're using the GPU in this session, and the other thing I want to mention is you can see here how much of the in-session disk space you've used. So you'll notice in the tiny, tiny text up top, it'll show RAM used 1.61 gigabytes of 12.72, and disk space used 32 gigs of 68 gigs. And those are all things that can change. Oh, the other thing I forgot to mention, if you go to runtime type, if you have Google Colab Premium, there'll be another drop-down box as well for standard session and high RAM session. You can actually, so if I recall correctly, the high RAM session has, it's either 32 or 64 gigs of RAM available, which for some machine learning use cases can be necessary. I'm going to exit. So all of this is going on in Google Colab. I'm going to switch to a different online Jupyter Notebook session for just a moment to demonstrate something, because that one wasn't proving as useful. I'm going to go to mine and let me do. Okay. This one probably is the better one to work with. Let me just confirm. Yes. Okay. So this notebook here, don't worry about following along with the code in this, because this is not using TensorFlow. This is using something different called FastAI. But I just wanted to demonstrate the differences between running these with a GPU versus, or with a CPU versus a GPU. So this is, and of course they've changed the interface just a little, so bear with me for just a moment. Okay. So this one's running with a GPU. I'm going to leave it running with a GPU for now. What you see here is something called a Kaggle notebook. This is my these are the notebooks I tend to prefer for online use because they're slightly different in how they handle stored data stored between sessions. And there's a few more things about how you publish the notebook that just make it a little bit nicer to show off. It's not necessarily a better platform, it's just my preferred one. There are some limitations and I wouldn't necessarily recommend starting with this for class. So first, let me run everything down to here. So right now I'm running this notebook with a GPU and we're going to see everything still loading. Let me make sure that the probably should have done a dry run of this first just to make sure everything would still run properly.
No, first time through, it proves shows us what we can expect.
Well, so to explain this notebook here is using a different framework. So what we'll be using in the class is called TensorFlow, and it's what a lot of people use for deep learning. It was the most popular framework for a long time. It is, I'm not sure if it's still the most popular. There is, its closest competitor is called PyTorch, and this notebook here uses FastAI. FastAI is like a wrapper that sits on top of PyTorch and makes certain other things simpler. So this is a notebook that's setting up a training environment to train on images. So this is a deep learning neural net that's working on images, and it's specifically trying to classify whether or not determine whether or not or the level of cancer that a person has based on their prostate biopsy. And you can see down here that we've got that this training's moving along at a pretty slow rate. And I'm just going to have it complete a couple of epochs to show things off. And while it's going through, I'll try and explain some concepts. Since the class is going through with TensorFlow, I would not recommend trying to pick up any other frameworks. People will tell you that there's various advantages to PyTorch or TensorFlow or various other ones. I wouldn't, because the class is going to be going through with TensorFlow, I wouldn't try picking up other frameworks because it can get very confusing if you're just starting out. Right now, anything that you can do in PyTorch, you can also do in TensorFlow and vice versa, with a few exceptions of things that are just recently published papers that are high-end concepts that may take a little while to trickle from one library to the other. But for the vast majority of use cases, you can use either and still get the job done. One library may be slightly more efficient than the other, but only slightly. In speaking to machine learning engineers, the tool that's best to use is whatever your company's already using. That being said, there are a lot of libraries that sit on top of either TensorFlow or PyTorch and make them simpler. This course is going to be talking about Keras, which is a library that takes a lot of the boilerplate code and does it for you so it's easier to write. There's still a lot of boilerplate code you have to write to be able to do anything in TensorFlow, but it takes a lot of it away for you. It makes it somewhat simpler. Why is this? Actually, let me see. Oh, that's why. Wow, I picked a terrible example for this. So if you remember when I was mentioning before with this image here, when you're training a neural network, you've got the input layer has to represent every single pixel of an image, or every feature if you're using tabular data. The network that I have going right now is actually taking images that are size 784 by 784. So this one is a little bit bigger than what you'd realistically see for many use cases. And in fact, actually, well, no, I'm going to leave it like this for now. No, let me make this simpler. I'm going to cancel that, and I'm going to change this to size 196. Okay. Just because I do want to show this I want to show a reasonable amount of time. Excuse me. So now we're seeing this move along significantly faster, but I just want to get to the point where you can, go ahead.
Well, I was gonna say, what was it that you changed in the images? Did you just lower the resolution that was being evaluated?
Yeah, I'm just changing the resolution to make it simpler.
Yeah, okay.
In fast AI, it's very quick and simple to do that. In TensorFlow and Keras, there's a few more steps that would need to be done. But again, fast AI is a wrapper that sits on top of PyTorch to take away a lot of the boilerplate code. So we'll have that running for just a little while, just to show you how quick that moves. And right now it's running on a GPU. I just want to get to a point where it actually finishes a training cycle so I can show you what the time is and then change to a CPU to show you the other. While that's running, actually, does anyone have any questions or anything that I've gone over too quickly?
I was gonna ask you, when you say I'm gonna let it run through a couple of training sessions, what do you mean by that? Like, what are you watching that's gonna get to some point that you're gonna say, oh, I've got it?
Oh, actually, I guess that's a really good point in deep learning that we haven't seen in some of the other machine learning steps. So for deep learning, there is what's called an epoch. And actually, let me talk about epochs and mini batches, because that's a very useful subject to bring up this early. When in deep learning, you don't just train a network once. You have your set of training data, and you're going to feed all of that into a model, and the model is going to learn based on that information. So it's going to try and fit itself to that data, and then run a set of predictions from that to evaluate what the training error or what the error is between the model trained once and then on a holdout set. So essentially in deep learning, you have to have a training set and a validation set. So it'll run through the training set. It will adjust what's called the weights and biases at each node. So every single node performs, each node performs an operation. It modifies the weights for those operations, so what those values are, based on the training data, or based on the difference between training accuracy and evaluation, using a process called backpropagation, which I don't want to go into too much detail because I don't want to overload you guys with too much at once, but all the training data goes through, it changes the weights and biases to fit that training data. And then when it runs evaluation, it looks at the difference between sorry, I'm explaining it poorly. Let me start from the beginning. The training data goes into, the training data goes into the neural network, and at each step, it tries to perform those operations so that at the end output layer, it's able to make a prediction based on each of the operations that came before it. In this case, you're seeing a network that has two outputs. So for instance, tumor, not tumor. and it runs all the way through, and at the end, it makes a prediction. And based on the accuracy of that prediction, it's going to use back propagation to adjust the weights and biases of each node, so the operations that occur at each node, to produce a more accurate output. And it'll run through that entire set of training data once, and that's called an epoch. And at the end, it will do another set of computations on what's called the validation data, which is a separate set of data, and it will determine what its error was. And it will, if it's written properly, it'll show you what the error is for training and what the error was for validation. And then, but you don't do just one epoch, you're going to do, say, 20 epochs. So it'll complete that full set, and that full set's called an epoch. And if we go back here now, it's almost finished. You'll have, at the end of one epoch, you're going to have a set, you'll get your results, and then you'll go back and get a sorry, 1 second. You'll run through it again to improve the accuracy, and you're gonna run 20 or 30 or 50 different epochs over it, so that the model can keep evaluating and try to improve, and at the end turn out to be a much better model than what it started with. Does that make sense?
Yes.
So what's going on here is I'm actually trying to run through one epoch. And it's taking a little bit long because this is a large data set, and yeah, I probably should have picked a better example than this. I feel kind of silly. Yeah, I should have picked a better example. There's 8,000 images in this data set.
Oh, damn. I didn't realize it was that many.
Yeah. Well, this was for a competition.
Oh, hey, while we're waiting, if you don't mind me asking, so when you say competitions, what kind of competitions are you doing? Is it are they here in Texas, or what?
So
they
this
online?
one, so this was an international competition. This one was online. If you go to, and I'm using their service right now. If you go to Kaggle, they have a section called Compete. And 1 second, I did not mean to make a new tab with this. They have actual competitions that you can join, and you put machine learning algorithms to the test to see if you can beat other data scientists. And I've competed in quite a few of these. I've also competed in some smaller competitions. I find it enjoyable.
I was going to ask you this. So like these competitions, for example, you're presented with a problem. Is that or some data set and some desire to observe something or infer something from the data set?
Oh,
and
let me interrupt you for 1 moment.
Oh yeah, go ahead.
I'm going to do the next step for this. So
yeah.
I just trained a model to run through the entire data set and make a series of predictions, and it took 7 minutes and 13 seconds to do one training epoch here using a GPU. I'm now going to change this to a CPU, and I'm going to run this entire thing again, and it's going to take some more time.
Much longer.
So yes. So I'm going to have this one running in the background, and we're going to see if it manages to complete one epoch by the time that this study session finishes. So I'm going to just make a quick note as soon as.
Hey, Neil, I got to go, but I'll watch the video in a little bit whenever you're done. But thanks for your time. Thanks for everything. I'm following you here, but I got to go, unfortunately. But I'll
Quite all right.
Guys, thanks a lot.
Hey, Neil, do we have a control over the epochs that we want to run?
Yes, epochs are going to be one of the hyperparameters that you're going to select when you're doing training.
And how many of them you have selected? 2?
For this one, I just have 2 epochs selected for this particular case. Depending on what your problem is and the model that you're using, you could be running anywhere from 1 epoch to 100 epochs in some cases.
Each epoch is intended to refine the model further, correct?
Correct. Yeah, and it's essentially just referring to the model running through the entire data set once. And one moment, I just want to get it to the point where this is actually running so I can make a note of what time that starts. That is still running at 196. Okay, so training has just started and the time right now is 6:47. We'll see if this manages to complete before, if it manages to complete a cycle before the end of this study session. So what was the next, someone had asked a question. Oh, right, it was on competitions, right?
Yeah, I was wondering. You're presented with a data set, some objective of trying to observe some pattern in the data, and then from there on, it's up to you to kind of pick your path to completing the objective, right?
Correct. So, for instance, one of the ones that a lot of people start out with is the house prices competition. And this one, you're given 2 sets of data. You've got a training set and a test set, and you use the training set to train a machine learning algorithm and to predict what the price is, and then you use the test set to make a series of predictions, and then you submit that series of predictions to the competition and see how close you got. And it evaluates how close yours is versus everyone else's.
I see. And the test set or the test data set, I presume, is something that's not revealed to you, right? You come up with your algorithm and then you run it on the test set along with everybody else to try to see who gets the best result.
Yeah, so the test set in this case has everything except for the price listed in it. So you use all of these features to make your predictions, and then you submit those predictions and they will compare those predictions to the actual values.
And that actually brings up another great question for me, or at least something that's plaguing me is, okay, so I've gone through and I've created the algorithm, right? I've run through whatever path I'm going to take into training my algorithm. How does like, is there a possibility to give it a single set of data that
Yes.
How do I say this? Does that make sense? Like, I have
to
my
run
trained
inference
algorithm
on just a single case. Yes, you can do that.
Yes.
Okay. If you want to see a specific example of how to well, there's a few examples, but why am I?
I guess because what really was sort of conceptually kind of away from me, or getting away from me, was like, we're doing all this work to train and then test, but the end result is really just a value on the accuracy of the model on our trade, or like on our data set. And that's what it was always like, well, when do we get to do just a single observation of data, or make an inference on a single data point?
Yes.
Okay.
So, and I'll share this link with everyone. This is a notebook that I put together sometime last year. No, it was earlier this year. And the purpose of it was to, one second, where is, there's Chad. So the purpose of this notebook was to create an algorithm to predict what someone's level of stress is based on a set of features. And at the end here, what I actually do is and I'm just going to go through and actually run this. This is one that does not require a GPU because this is just using machine learning.
Wait, say that again. This one doesn't require GPU because it's just machine learning? What do you mean?
Oh, this one's just using a random forest algorithm, which would not benefit from GPU because random forest, first sklearn's random forest package is not optimized for using GPUs, but random forests based on their type of calculation, I'm not sure if you could get a computational advantage by running it on a GPU.
But what would be the contrast to that? I guess when you say this one wouldn't benefit because of what
it's the type of calculation being used. So a CPU is able to a specific processor on a CPU is able to do much more complicated tasks than a single core on a graphics card. A single core can only do so complicated of a computation, really, or can't really do anything overly complicated. The advantage is that a graphics card has 1 or 2 or 3 or 4,000 different cores that it can perform computations on at a time. So it could assign one core to perform the task of one neuron, whereas a CPU only is going to have 4 or 6 or 8 or 10 or 12 cores. It's not going to have enough cores to be able to do a bunch of computations in parallel, but it can do much more beefier computations. Does that make sense?
Yeah, I follow all that. And but the reason you're saying, I guess what threw me off is you said this is only machine learning as opposed to like AI. Is that what you're?
Yeah. So first up, let me put the disclosure here that what I'm about to state is something that is opinion. There are people who disagree with my opinion, and there are people who agree with my opinion, who are way more qualified to make arguments about it. If you were to create a Venn diagram of it, you would have one large bubble that's machine learning, and in that would be a smaller bubble called deep learning. So to me, all deep learning is machine learning. Deep learning is just a specific subfield of machine learning.
Gotcha.
There are people who would disagree and say that deep learning is different, or there is some overlap, but it's not the same. I personally disagree with that because I don't see it as being functionally different than machine learning. I just consider it to be more specific.
So is that because like deep learning would refer more to neural networks or something of that, like a?
Yes. So the definition of deep learning, if I recall correctly, I'm going to be quoting Andrew Ng on this one. It is deep learning if there is one or more hidden layers. And if you look here, when talking about neural networks, you have the input layer here and you have the output layer here. The hidden layers refer to all the layers in between. Anywho, so moving back to this for just a moment, here what I'm doing is I have a data set called the stress and achievement or well-being and lifestyle data. And this is data that was taken from user surveys by, I'm trying to remember, if you look here, it's a lifestyle coach that was trying to look at what causes authentic happiness in a person's life. And they've got various books on the subject, but I want to say this was specifically done for 360-degree living. I want to say that's the one that this was specifically done for.
Okay.
Maybe not. Could be a little bit off. It's been a while since I've worked on this one. But the specific challenge of this data set is trying to use machine learning to predict what someone's level of stress was in their life and what the level of personal achievement was. And I have 2 notebooks for this. One of these is a deep exploration of it and application by various models. And this one here is actually just using that model to make predictions for an individual. So here I have this is just the entire training and setup phase. And I could actually, what I should have done is actually saved the model and then just loaded it here to make this notebook that much faster, but I was lazy. Here, it actually will prompt the user with the question. So I have to answer here. So the question, fruits and veggies, that one refers to number of servings per day. And for me, I get, how much am I getting right now? Probably just 2. Places visited, so that's, oh, I should have gone into more detail there. Actually, I've only visited probably 3 places in the of significance in the past year. Core circle, don't judge me. Supporting others, that one. I don't think there's that many in my life that I'm supporting right now. Social network, probably not great now either. Donations, that one's been bad. I have not been doing donations this year. I used to be much better about that. BMI, I'm going to guess. To do completed, not great on that either. Man, flow is going to be 5 right now. I'm okay on that. Daily steps, I'm over 10,000 right now. I'm averaging 22,000 steps a day. Life vision, that one.
22,000? Jesus,
Yes.
you just walk everywhere? I mean, I get a lot of steps. I'm like at the 13,000, and that's like, all right, we're doing all right.
So right now I'm between more serious jobs. So I'm working at the Amazon warehouse, and that's why I'm averaging 22,000 steps per day.
I see. You're just walking around all day. Yeah.
Yes.
So literally
dragging pallets everywhere. Hours of sleep, I'm probably averaging 7. I'm not sure. I'm not doing well. Lost vacation. Ooh. Actually, I think it's probably just that right now. Daily shouting. I'm trying to remember that. I'm going to put that as 3. Sufficient income. I'd say it's sufficient. Everyone would define that differently. Personal awards. Doing okay there. Time for passion. Making more time for that these days. Daily meditation. Not doing well on that. Age. I guess I'm in that one still. And gender. Okay. So before I run the next thing, this entire piece right here, I'm actually just creating a single entry data frame. And if I look here, this is what that is. I've just created a series. I've been filling in the blanks for a data frame that just has those values. And then I feed all of those values in there to make a prediction. And if I go here, it's predicting my daily stress on a scale of 1 to 10 is 2.44. And number of lifetime achievements is 3.87, which is obviously not a sensible answer, but yeah.
Yeah.
And so when you're working with sklearn, and in fact, actually, when you're working with the vast majority of machine learning frameworks in Python, it's actually just going to be model name dot predict. So you're going to do just my model dot predict, and then you're going to put in what you're making the predictions on. And in this case, the first element or the element 1 refers to the prediction from daily stress, and element 2 refers to the prediction of lifetime achievement. And so I put some fancy text around to show, but I can actually just run I can run predictions one at a time. The only thing to be careful of is you just need to read the documentation to make sure that when you're running .predict, that it's to understand what the output's supposed to look like. I'm gonna go over here for just. Okay, so taking a pause from that for a moment, if you remember correctly, when we were doing the GPU training, it took 7 minutes to do one iteration through the data. It's been 15 minutes now, and if you look, we are at 20. It has only gone through the data about 27.5% of the data so far on the CPU. So just nifty little thing. I'll probably bounce back to that a couple of times. But you can run inference on single cases that way. The common way to do it is for sklearn, .predict typically will tell you, will give you the outcome. So it'll say that this is a positive case, or this is a negative case, or this is what the regression outputs as the likelihood or whatever. The other way that you'll see it for most deep learning libraries is if you're running classification, instead of saying it's a positive case or it's a negative case, it'll actually give you two values. Let's say it's binary classification that you're doing. Most deep learning libraries will actually tell you it is a 0.75 chance of being a positive case and a 0.25 chance of being a negative case. So that's what I mean when I say double check the documentation for the framework you're using, because some of them will give you different explanations for, or will give you different values when you run predict.
I see.
Okay. Any other questions?
I don't think so. At least not for me.
Sonny, did you have any?
No, Neil, I'm good.
Okay.
Thanks for all this explanation.
So in addition to running things on Colab, or to take a moment to go back to Colab, you can, with the when you're using Colab standard, so just the free version of it, you have access to basic GPUs and basic TPUs just by going to runtime type. You can actually select GPU or TPU, and there's even this little helpful thing that'll tell you about it. If you were using the free version of Colab, you get there's a specific tier of GPUs that you get access to. If you decide to go for Google Colab Premium, which is $9.99 per month in the US, I believe there's different pricing models elsewhere. There are faster GPUs that you can also have access to, but it's based on availability, so they may not be available. You're not guaranteed availability on that. You also can get access to more memory and some other stuff as well. So yeah, the other thing to mention is you get with Google Colab regular. Your sessions will time out if you stop using them after a certain amount of time. I want to say if it's idle for an hour, it'll time out and disconnect. For premium, it'll stay idle for much longer and be just fine. And you can run longer sessions with premium as well. I don't remember the exacts off the top of my head. If you look here, Collaboratory has, let me actually go through it. Okay. Nope, I don't remember. Okay, yeah. There's session time limits and whatnot, but I'm not sure off the top of my head what they are. The other thing I wanted to mention, and actually, let me see if they have it here. If for whatever reason, I guess it's not actually available through here right now. In addition to Google Collaboratory, and it's not going to be relevant during class, but let's say after class, you're working with a company and they want you to train a deep learning network on, say, 1 million images. They have a huge data set to work for. You're doing image segmentation for healthcare data, and they have 1 million images to train on. Google Collaboratory would not be a good case for that because you're going to require greater resources than what's available here. There's also Google AI notebooks, I think is what they're called now. Let me see. Google Cloud AI notebooks. And for those, just to open that up real quick to show you the interface. This uses GCP's platform, so Google Cloud Platform. And here, okay, one moment. I'm trying to remember. Notebooks. Here, you can create, how do I create custom notebooks? Sorry, it's been a little bit since I've used this. Let's do that, right?
Did I hear you right? You said these are new this is a new offering from Google for AI and stuff like that?
This isn't a new offering. This is just a way. So, okay. Where is, nope. I think I'm gonna, am I on the wrong? Nope, this is the correct account. Shoot. The Google, why is this not coming up? Okay, I guess I need to set up billing to be able to use it on this account right now. For Google Cloud AI notebooks, those are notebooks like Colab, except you can custom allocate resources, and those ones have specialized billing for them. So again, the case, for instance, where you're going to be training on 1,000 or 1 million images, you can't run that in a Google Colab notebook effectively. It's just going to take way more resources than what you have available. For that, you can open up an online notebook and you can actually select, hey, I want to use these 4 GPUs for training. I need this much cloud storage available to hold the data set. I'm going to be running for this amount of time and I need these processors allocated to this task. And you can custom select the resources that you need and allocate them. And it'll show you this is what the cost per hour is to run it. So for instance, using FastAI's library, there's something called ImageNet. You can train a model on ImageNet, which is a million images. FastAI's library, I think, was able to get that done in, I want to say it was 8 hours for $40 using Amazon service. And I want to say they had 4 GPUs attached to that task or something silly like that.
What size were those images? Like, what's the resolution on those million images? Do you know?
Let me check. All images. Wait, really?
64 by 60 is a favicon.
Okay, let me check. Okay. Okay. So for ImageNet, it's typically resized to 256 by 256. So what you're feeding into the image, or what you're feeding into the algorithm, is 256 by 256. They're not all that size, but that's what they're changed to. But yeah, you can use Google AI, Google AI Cloud Notebooks. There's also Amazon has their own service for it as well, as does IBM, as does Microsoft. I tend to stick to Google Cloud Platform because it's what I know. But I'm not sure, I don't know what the pros and cons of the various platforms are for it. Other than I just think Google has a much better free tier than other services.
That's fair.
Okay. So the next thing I want to show off real quick, I'm going to create a new notebook here, and feel free to follow along. We're going to do just machine learning in this one because I want to explain the other area that people get tripped up on with Colab is memory usage. So I just want to show that. So if you want, you can code along with me. If not, you don't have to. In this next part, I'm going to demonstrate loading data from 3 different sources, and essentially how to understand what file paths look like here. So in Colab, if I open this window right here and I go to the folder, there's you'll see 3 options here for refresh, mount, and I'm not sure what this one does. And here we have sample data. So I'm actually going to real quick import NumPy as NP, import pandas as PD. Please ignore the fireworks. I don't remember how to turn those off. Actually, let me see if I can turn those off because those have been annoying me for a while. Where is notebook settings? Negative. It's not there. There's the bigger one. I'm just going to have to live with that for now, I think. Nope. Don't have that enabled right now. Nope. Okay. So for here, here in the sample data, I want to load in and read the one labeled California Housing CSV. So if I look at the file right here in this preview files menu and I select the 3 dots, I can select copy file path, and that'll copy it to my clipboard. So I can just hit Control V and it'll be right there. And then it'll show me this is all the data that's available. Following along so far?
Yeah.
Okay. Now, if, for instance, you wanted to get data that's not included in this sample data here, because obviously not all problems can be solved by one of these 6 files, you can, yes, that's what it is. If you go here to this icon, you can go to your own folder and or go onto your own machine and upload data. Now, the important thing to remember is when you upload files to this session, your files will expire at the end of the session. So when you close out of Google Colaboratory, anything you've uploaded to Google Colaboratory is gone. You can save the notebook So all the code will still be there, but the data won't still be attached. So I'm going to put this, well, yeah, and I'm just going to change a couple of things here. And so once again, I select the file itself, hit the 3 dots, and hit copy file path. And now this is the data I've uploaded, and I've got access to it right here. So does this make sense so far?
Yeah. I do have this question because you said that second button there was to mount. Is that like mounting a drive on your PC so you have access to the data there locally, other than
Yes.
like having a, okay.
So that's the next. That's the next one. And give me 1 second just to see. I'm going to look at my Google Drive to see which one's actually got some. If I have where the file I want to use is, because I have 2 Google accounts. Huh. Fascinating. I did not know I had that. Is that?
Hey, how do you keep those two? How do you keep those 2 Google accounts organized? Like in terms of when you're saving things. Well, I guess that's an incorrect question. Do you use the 2 drives on your phone?
Oh yeah, I'll use the 2 drives on my phone or I'll access the 2 drives from my phone sometimes. Realistically, I have one account that I use for that I title my unprofessional account, and I have one account that's my professional account. And it's academic and professional stuff go on the professional account, other things go on the other account. This is my
Do you make use? Oh, sorry, I didn't mean to interrupt you. I was going to ask you, do you make use of any of the auto upload features that come with Google Drive?
Negative.
Okay. Yeah,
I just don't find them useful for me.
Gotcha.
Is this one it? Okay. Where is? Oh, okay. There's that one. Yeah. So yeah, that'll work just fine. So where was I? This tab. I have too many tabs. Let me move that here to make it easier. So now I'm just going to create one more. So now I'm going to go here to Mount Drive, and I actually have to get an did I hit the wrong button? No, I didn't. Oh, weird. Okay. So when you hit Mount Drive, there's a couple of things that can pop up. Depending on how you have your session configured, it may prompt you for an API key, and it'll walk you through how to get that. It's very simple to do. In my case, it just automatically did that for me, which I didn't know I had it set up to do that.
I was gonna say, then yeah, you had to have had it configured that way.
Yeah. So I had to mount the drive, which, by the way, well, let me just continue with this and demonstrate. So here I have my drive, which is its own folder. Inside of that, I have a specific file I'm going to, and I'm just going to grab that data set right there and copy the file path. And that one's going to take a little bit longer because it's a bigger data set. But it was able to read all of that off my Google Drive. Now, one thing I'll point out, this, oh goodness, don't open that. This folder right here contains, I want to say 8 gigs worth of photos. The only way I could actually access those images is to upload them to my Google Drive and mount the Google Drive, because I don't have it would be impractical for me to upload 8 gigs of photos to a Google Colab session each and every time I started Google Colab. I don't even know if I could do that. Actually, I think you probably can. Yeah, it looks like you could.
Yeah, I do have this question. When you mount a drive, will it work with a local drive, or does it have to be something through the?
It has to be Google.
Like a
it has to be
web-based?
your Google Drive. It'll.
Oh, okay.
Well,
okay.
that's not exactly true. If you wanted to create a API for it, you could probably mount your local drive to Google Colab, but it means that any time that it was accessing memory,
Still got to
it
go
would
through
have
the
to,
web, I guess. Right?
yeah, so it would be very slow. You could do it. There's nothing stopping you. It just would be very slow.
Okay.
Depending on what server you have your stuff hosted on, it might not be too slow to do it that way, but it still means anything not written to RAM is going to be is going to have that delay due to latency attached to it. The Google Cloud servers that they have running here are actually really impressive for their speed. Anytime you have to download something into a session from one server to another, it's just instantaneous. Just really fantastic. And so the next thing I'm going to do real quick is I'm going to save this notebook. And now I'm going to how do I end this one? Well, I guess close that. Going to reopen Google Colab. That's not what I meant to do. So I'm going to go to this one to manage runtimes, and I'm going to terminate that one just because I want that closed. Now I'm going to go File, Open Notebook. So here I can select any of the one. Here I can go from recent. I can also try and pull ones that I have saved to my Google Drive, which this one is. I can pull from my GitHub if I have that linked, or I can put the GitHub URL here. And I can also upload Jupyter notebooks myself and run them that way. So here, I'm just restarting this notebook, and I want to show something off real quick. So I run the first cell, everything goes fine because it's just NumPy and pandas. Oh, sorry. This is here showing that it's still connecting to the runtime. Now I'm doing this again, and the sample drive's still there. If I go to run this, it's going to tell me there's no such file. And if I look at the folders here, I'm seeing my Google Drive is still here and mounted. The sample drive is still here and mounted, but notice how the files I uploaded are no longer there. So I'd actually have to go back here, select this data again, and then once that's uploaded, then I can rerun this and get that data. By the way, I don't know how I have it enabled, but it'll automatically link to my Google Drive much quicker. Normally, you'd actually have to reattach the API key to the session. Again, it's not a very complicated process to do. Google walks you through it. Just note that it's something you might have to do with each startup. I don't know how I got that linked properly.
I was gonna say, so then each time you go, either way, you still got to reestablish that data connection.
Correct.
Yeah.
Now, the one reason that I like, or one of the reasons that I prefer Kaggle, you'll notice I never had to connect my data when I was running this notebook here. That's because I actually have I have that data saved as a data set, and I have it saved to point to that data. So every time I restart this notebook, it'll already know to load this data into the notebook session.
I see. So does that mean you sent the data, like Kaggle has that data hosted for you that you need for that notebook?
Correct.
Is that
So
right?
for instance, there's this one right here, which is the data set from the competition. and that data set's already linked. So it just links to that competition data set. And then this one, actually for both of these, it actually links to not a data set that I have saved, but it links to the outputs of another notebook. So it actually, the data set here that it's linking to is actually the output of a notebook.
So you can kind of chain them together in terms of like run one notebook that does one operation, and then take the resultant of that one, and you can plug it into another notebook later.
Correct. Yeah. And you can even host just data sets themselves. I will mention the limitation that Kaggle has is that they only have a free tier. So you can only host so much data. You can only use so much GPU time. Once you're out, that's it. You're done. Google Colab, if you're willing to buy more Google Drive space, you can have more space to host your files. If you want to pay, you can get faster GPUs and access to faster GPUs. If you want more, you can go to Google AI Cloud Notebooks and get even more resources and custom allocate them. So there's a lot of options there.
Yeah, sky's the limit with whatever your needs are. You know, you can make it happen.
And then, one other thing to mention, a nifty feature for Google Colab is you can, in addition to saving it, so this will save it to your Google Drive, you can make a copy of it in your Google Drive, and you can also push to GitHub as well. So, one second. I can actually put this directly in, link that directly into a repository and send it there, and it will even have that little thing. So if I go onto GitHub, oops. Interesting, I'll have to look at that sometime. Here, you'll see files test. And if I select that notebook, it'll even show me open in Google Colab. So I can open that notebook in Colab and mess around with it. Now, again, well, thanks for being around, Sonny. I hope you you found this useful, and I appreciate your participation.
Sure, Neil. Thank you.
Yeah, so here I can reopen the notebook in Colab. Makes it pretty easy and accessible.
Neil, would you be sharing this recording?
Yeah, so I will upload this recording to YouTube, and then I'll post the link tonight once that finishes. I don't know how long it's going to take to get that posted. Truthfully, I've only posted one other video to YouTube in the last decade, so I'm not 100% sure what the timing requirements will be.
Okay, no problem. Thank you.
My pleasure.
Yeah, that'll be quick. It's just you and I, right?
Yes. So feel free to ask any questions. I'm more than happy to go as off topic as you want.
Yeah, that's kind of, I was gonna go ahead and cut to the chase here on just a couple of so we've gone through setting all these up. I will tell you, going through this Google configuration that you have is very useful, because I'm surprised that's not what they did from the beginning.
So it's useful to be able, you should understand how to set this stuff up on your own computer, and having Anaconda on your own computer to be able to run and save stuff is important.
Yeah.
There's also the advantage that it's much easier to pause stuff and pick it back up when you're running it on your own machine. Now, the downside is cloud environment, or the advantage that cloud environments give you is what your base machine isn't going to be a limitation. So when I'm working on a competition, I tend to use cloud environments because I can start working on stuff on my home machine, checkpoint it, and then pick it. I can be at work and say, an idea occurs to me of, if I change these three hyperparameters, I might be able to make some improvements. So I'll just load the notebook up on my phone and update it. So I can update from any smart device and just rerun it.
But let me ask you this. So then the notebooks that you have saved, like you saved it to your Google Drive, I can
Correct.
still open that locally on my own PC with Jupyter, or is that like I've opened it in Google? I'm sorry, I opened it in Google.
You can run it on your local
Colab.
machine. So if you go to File, you can actually download it as either a Python notebook, which will keep it as a Jupyter notebook, or you can open it as a Python, or you can download it as a Python script instead, which will collapse all of this into what is essentially a single cell.
Yeah, it's just a bunch of code.
Yeah.
Right? Yeah. Well, anyway, like I was saying, man, thanks a lot for going through that setup, because it does. Yeah, I know. It gives me a solution to keep all my data, because I'm working from a different PC, and I had to keep saving files to like well, I guess either online or on a external drive, and being able to just have it saved directly to Google Drive would make it a lot easier. I just didn't know there was a way to open it from there without going through the automatic, where it'll replicate whatever cloud files I have on my local drive. Without doing that configuration, I didn't have a way of doing it, which was a bit frustrating. But the other one I was going to ask you is TensorFlow. So we talked a little bit about it at the beginning, but TensorFlow, setting it up on the PC, what do you have to do to set it up?
Okay, so that one I was actually going to learn as I went, because I haven't installed TensorFlow. I haven't installed TensorFlow on a machine in
a while.
It's been a year or two. I'm not entirely sure. I had it on my previous machine, which, as I said, I recently rebuilt this, so I had to switch. I had to switch what my workstation was for a while. I recently rebuilt this computer, which is why I have thermal readings going on my other screen right now, so I know what everything is.
Oh yeah, sure.
Various things monitoring.
Well, tell me this. Give me like a big picture overview, like kind of a preface for how detailed this would be. Is it like go to the internet, download a package, install it on your PC, and then you can I guess query it inside of using Python, or is it like you have to do some configuration steps in Python as well, outside of that, I guess?
So I'm actually going to go through it right now. So the way it was last time, so I don't know how it's going to be this time, but the way it was last time was I opened up Jupyter Notebook, did conda install TensorFlow, and that downloaded, and then there was 2 dependencies, if I recall correctly, that I also had to do the exact same steps with.
And you did it inside of the Jupyter Notebook?
Yep. So, or not conda install, I think it's pip install.
Gotcha.
So I'm going to do. Don't laugh at me. I've been sticking to clouds for too long.
I can't even watch. I left the office about, I don't know, 30 minutes ago. So like I really haven't been watching. I've been listening, kind of paying attention to what's going on, but I really haven't been watching. When you said you were going to turn off the fireworks, it's like, no, you got to enjoy them. They're celebratory, but I couldn't see what they looked like anyway.
Okay. Come on, brain. You remember what you're doing. Okay.
TensorFlow.
Okay. I'm just trying to remember. Okay. Just trying to remember what the specific command is. Okay. Okay. Is it just that?
What is it? You're keeping me in suspense.
Let me make sure it is before I say it.
Yeah, that's
So
a better
essentially,
idea.
yeah. Essentially, you're opening up a notebook, and all I'm putting in this first cell is just pip install TensorFlow. And that command is installing the TensorFlow library, and I'm making I'll see how it's running. And I'm just going to put in the next one. Whoa, okay.
So I just went to the TensorFlow website.
Yes. Oh, I misspelled that. Go ahead.
Is it those two? When you say there's two packages, are you talking about the? It just says right there, TensorFlow 2 packages are available, and it's like TensorFlow, and then another bullet says, I guess it's TF-nightly. Is that right?
1 second.
Oh, wait a second. That says unstable.
Okay, 1 moment.
Yeah, go for it.
Make sure I have that installed properly. Okay, what is the error there?
Restart. Oh, I missed it.
That one's still there. I just want to actually fix this before I go into it.
No, go for it.
Okay. Okay. So let me make sure that this is what I think it is. I think I actually need to, I have another dependency I need to install first. Failed to load native TensorFlow runtime for some common reasons. The solution. Okay. If I'm not mistaken, this one's going to be that I need the C++ runtime or some stuff for the C++ runtime to be able to get it going. Let me see. This one says DLL load failed while importing specified. I don't have the specific one there. Oh, wait.
How are you determining which? You said you might need another background. Was it distributable? Is that what you said?
Distribution.
Distribution. How do you
So
know which one you need?
this one's from memory.
I gotcha.
So TensorFlow does have some dependencies, and I'm trying to remember what those are. So,
but like just off the top of your head is kind of what I'm.
Yeah, that's what I was trying to go to. So,
Gotcha. Okay.
Okay, I need Microsoft Visual C++ redistributable. So. Let me 1 second. Because I want to do that right here. Oh. Okay. Visual Studio 215, 17, 19. x86. Yeah. Okay. I think this is the right
No
one.
luck.
I'm just trying to make sure I'm
Hey,
doing
man.
this right.
I'm fly on the wall over here. I'm just listening to how you go through your
Okay.
process.
Googling mostly.
That's the same thing I do. I try to, and there's one, somebody's done it before. I know this works for people, so there has to be a solution, right?
Actually, let me do a quick Google check, and then I'll verbally walk through what I'm doing.
I'm just trying to fit in as much as possible. I'm like I told you, I'm driving home.
Okay, that'll work just fine, I think. Let's see. All right. Okay, so what I'm doing right now, because I'm running this on Windows, is I'm also downloading Microsoft Visual C++, because that's required to build one of the packages.
I see.
And as a little side note, TensorFlow and PyTorch both use, under the hood, use some C and some C++, depending on which packages. I actually think TensorFlow uses C mostly, and it's PyTorch that uses C++, but I could be mistaken.
What? Let me ask you this: what does that do from a from like a user perspective? What does that change for me?
Nothing.
Because from a user, like I'm still using whatever they have. I guess, is that how you knew which redistributable you might need, or what, like the Visual Basic and all that stuff? Does that serve as a clue in at all?
Oh, I just knew how to do it because if you go to install, if you Google install TensorFlow, you'll get to this page right here. And it'll, so what you're looking for here is there's the first part that says TensorFlow 2 packages, and then that's the version there that I want.
Yeah.
And then I also want to go to the specific one on to install the environment for it. And I'm going to select Windows, and it'll say I need to go to Microsoft Visual C++ downloads, get this specific download, and install.
I see. Okay. Yeah, for a second there, I thought you were doing it from memory. Like, oh yeah, I just remember that this needs this and that kind of deal. Okay.
So
well, that was easy enough. So then, is that ready to go? If you put in, I guess if you try to use TensorFlow, it should run now, right? Because you've already got everything completed.
Yep. So cool. I just completed everything. So to walk through the steps that I just did, and to summarize, my apologies for the huge gap in time there, especially for anyone who is now watching this as a rerun at home. Essentially what I did was I went online to specifically figure out this command because I couldn't, I know it's stupid. I don't remember the pip command off the top of my head. I've been using Linux for the last 4 months. So now just finally coming back to Windows and doing things in the command line here is something I had to remember. I thought it was more complicated than pip install TensorFlow. Then just doing the upgrade here, which was unnecessary, but I wanted to double check. And then below here, this line, or at that point, I then went to, I followed the instructions right here for Windows, installed Visual C++, and then to make sure everything's running just fine, I ran this cell right here, which is import TensorFlow as tf.version, and it shows me version is 2.3.1. Whew. Next, I also am going to want Keras, which I don't think is already on here. If it was, I'd be surprised, but just to make sure. Nope. Make sure I also have that spelled right. I'm assuming this is probably also just going to be pip install Keras, but let me check. Nope, this is an old one. Well, actually, what's that? Yep. Okay. Oop. It sounds like someone just dropped. Okay. And oh. Okie dokie. So to walk through the next step, I just installed Keras using pip install, which is very quick, and ran right there. So just going to include all of this in the main notebook, but they're separate. If you're not using Windows and you're using Mac OS or Ubuntu, there's going to be some other steps, or there's going to be some slightly different steps. As you can see with Ubuntu, which was the operating system I was using before, there's just a couple of things to do in the command line that are pretty simple. It looks like Mac OS has some slightly longer things to put through using the Homebrew package manager, which I have not tried before. Raspberry Pi is similar, and I'm not sure what other is. Maybe you use none or use custom OSs for some of this stuff. Who knows? And voila. So going to leave that open for a little bit, and I'm just going to update this notebook because I'm going to share this notebook. This is nothing terribly complicated. You can do this on your own pretty easily. Cell above, and this one I'm just going to change to Markdown. Okay, so and this one actually, let me first change that. Okay, once you've done that, import TensorFlow as TF, which you can or do or skip if you prefer, and select version, and then that way you can just make sure that it did in fact install and what the version number is. Next, install Keras and check that one as well. And boom, you're done. It's all very simple. Going to quickly probably put a link. I'll put a link to this notebook and also the stress and achievement notebook in the comments of this video for anyone who's interested in seeing those and getting an idea. And looks like I'm just about to that 2-hour mark. And since that's been going on, let me pop back over here. So, and actually that worked out perfectly. So if you'll remember when we were talking about the difference between training on a GPU and training on a CPU, we were doing single training epoch with a GPU on this data set that contained 8,000 images. And when we were training on the GPU, it took 7 minutes, and I want to say it was like 13 seconds. We can see now that we finally managed to get a single epoch finished, and it took 1 hour and 1 minute. So almost 6 times as long using a CPU over a GPU. There are some other variables involved that will change exactly what the difference delta is, but that is not as big of a difference as you might see with certain other neural network architectures and use cases. I'll also mention that if you are training on a CPU if you're using tabular data instead of image data, that difference can be much smaller. So you can actually use neural networks to train on tabular data instead of image data, and for tabular data, you don't always need to use a GPU over a CPU, and that's because you're also using far fewer inputs per image. Anywho, all right, so basically I've just gone over the differences between some online cloud notebook hosting services, how to install and update TensorFlow and Keras for use for the class. I think that pretty much covers everything I intended to go over for this, since the last participants already dropped out. Thank you guys for joining. Thank you anyone who's decided to go through this. And I will probably post future study groups and the questions that they come up with in videos that I'm assuming I'm going to do on a bi-weekly basis. So we'll see. Thank you guys for watching.